Okay, so for lesson 4 today, points of intersections, we are going to look at doing what we did yesterday, but we did it algebraically yesterday, solving for that x in the exponent. What we're going to do now is we can actually do that by graphing. I'm not going to get you to do the graphing by hand. I'm just going to get you to do it using Desmos. Okay, so I'm going to show you an example of finding that point of intersection. Okay. So I want you to solve 2 to the exponent negative x equals 4 to the exponent x plus 3 graphically. Okay, then we're going to solve that equation algebraically, and then we're going to figure out what we notice about something that's similar. Okay, so I'm going to show you how to find or use Desmos to do this graphically. Okay, so what you're going to do is go to Desmos. Desmos.com/calculator on a separate browser. You're going to type in those two equations, 2 to the negative x. Just make sure that you're typing them as 2 separate equations, y equals 2 to the negative x, okay? The other one is y equals 4 to the x plus 3. Oops, keep it in the exponent. Come on. Okay, you might need brackets there to keep it up in the exponent. Sorry, it's the same thing though. Okay. Okay, there we go. Sorry, a little difficulty typing that in there. So just put brackets around that. Okay, so when you are putting that in your graphing calculator, you'll get something like this. Mine just ended up being 2 different colors, a red one versus a blue one when I did it before. Okay, so when you do that, you can see that there is a point of intersection where those graph crosses each other at 2, negative 2, 4. Okay, so when you do that on your graphing calculator, you would see that there's a point of intersection. So therefore, the solution to the original equation is x equals 2. So sorry, it should be negative 2. Is negative 2 because that is where your point of intersection is. Okay, so just make sure you have negative 2. Sorry, I mistyped that. Okay, then well, for solving the exponential equation 2 to the negative x equals 4 to the x plus 3 algebraically, it's going to be the exact same things that's the same thing as you did in the previous lesson. So because 2 can't go any lower as a base, but 4 can go into a base of 2, you're going to change that to 2 to the power of 2. Remember to keep that exponent x plus 3 in brackets. Then you're going to have 2 to the negative x equals 2. To use distributive property, 2x plus 6. Okay, then because your bases are the same, you can set your exponents equal to each other. Let's bring this positive 2x to the other side by subtracting it. So you're going to get negative x minus 2x is equal to 6, which becomes negative 3x is equal to 6. Divide both sides by negative 3, so then you should get x is equal to negative 2. So you'll notice that x equals negative 2 is the same as the solution from graphing. So therefore, what do you notice about the x-coordinate of the point of intersection found in part A and B? Well, the x-coordinate of the point of intersections of the 2 corresponding graphs is the same as the x value determined algebraically. Okay, so what realistically I'm saying there is that you can find the point of intersection algebraically, and you can find it by graphing. Okay, so a lot of your homework yesterday was all algebraically. Now today you're going to be doing it by graphing. Okay, when you are graphing for your homework, page 69, number 1 to 6 and 8, you are to use Desmos. Okay, so I'm never expecting you to graph these by hand, so make sure that you're using Desmos there. Okay, let me know if you have any questions or any difficulty with Desmos, but hopefully this is pretty straightforward. Good luck. Let me know if you have any questions.